Athletes, what we're going to do here is we're going to look at the written response from the January 2019 diploma, and we'll see what these questions look like. And we'll also talk a little bit about how to maximize your mark, how to avoid the little things that are costing students marks on these written questions. Normally, the written questions are fairly straightforward. So what's causing the decrease in marks is just missing a few easy things that we'll discuss here. All right, so if my voice can hold up for 3 written questions, 2 parts each, then we'll be just okay. All right, here's the first one from January 2019. So we've got 2 functions, f and g below, and there's 3 new functions being defined, k at x, j at x, h at x, and they're defined by some sort of function operation here, a composition, a division, and a subtraction. All right. Now, the first couple of things I want to note here immediately as I'm doing function operations, which generally is easier than some of our other units, is when there's subtraction, I want you to immediately think, the reason why they're giving subtraction is because it's easy to make a mistake when you're subtracting, say you're subtracting a negative, right? Division, they love to ask division because we get discontinuities, division by 0. And then, of course, composition can cause some issues of its own. All right, so we'll take a peek as we go through these things, what we have to do. So on every one of your 3 written questions, they're broken down into part A and part B. And one part's 2 marks, one part's 3 marks. Now, my suggestion is, friends, you've got scrap paper that comes in your diploma. Do all of your work on your scrap paper first, just like you would if it was an English essay. Get your first draft done, and then put your proper draft, what you're submitting to be marked, in the exam, okay? Communication's a big deal for us when we're marking these things in Edmonton. Make it clean, make it simple, get to the point, okay? So here we go. Determine which function, j at x or k at x, has a larger value when x is equal to 0. So the word determine is one of your directing words. It means you better show me some work, okay? If it said state, you can just put your answer. But the word determine in 30-1 means show me some work. Okay, so let's go figure these out. J at x or k at x. And when x is 0. Well, j at x is this composition of f and g. So what we're going to do here is we're going to say j at x is equal to the composition of f and g, like that. So we want j at x for when x is 0. Now, I personally don't care for this notation. Some teachers call it fog notation. I don't care for it myself. I like to rewrite it as this here. Okay, to me, it makes it just a little bit more clear as to what I'm doing. Now, notice I'm writing j at 0 the entire way down my page. I'm going to write that. It's going to make it nice and clear what I'm doing as I go step by step. You need those equal signs as you go down the page. That's a big deal in communication and mathematics. Okay, what's g at 0? So I go and I say, okay, what's g at 0? Well, when g is 0, our input's 0, our output's -3. So now we're f at -3. So now I say to myself, what's f at -3? So I go back up to f and I say, okay, my input's -3, my output is +1. And there it is. I'm going to box my answer, make it real clear for the person marking what my answer is. Now I'm going to go back and says, what's k at x? Okay, so k at x was equal to f at x over g at x. Our job here is to determine k at 0, which is f at 0 over g at 0. K at 0, again, we just have to go back up to our graphs and look at these things. So f at 0 is -2. K at 0, we've already found, is -3. So we divide these two things here. And of course, that leads us with +2/3. Now, at this point, I'm not just boxing my answers because I haven't actually answered the question, right? The question asks us, which one has the larger value when x is 0? Well, at this point, I want to make sure that I've actually answered the question. Well, I'm going to say that which one's got the larger value? Well, it's j at 0, right? So I'm going to say j at x has the larger value when x is equal to 0 compared to k at x. Okay, let's make sure that we leave nothing up to the marker's imagination. Okay, the marker can only mark what they see on the page. They can't assume anything. That's a big deal. We have to let them know exactly what we're thinking. Okay, and also, friends, avoid using the word it when referring to a function. Don't say it. It isn't the function. J at x is the function. H at x is the function. K at x is the function. So you've got to use descriptions and you need to be precise. All right. So now let's go see what part B is. So there's part A, not too bad for 2 marks. Part B says, sketch the graph of h at x on the coordinate plane below. Identify the coordinates of the y-intercept and state the domain of the function. Okay, so what we're going to do here, friends, remember, is when we're going to go back up, we're going to subtract these 2 functions. So h at x is equal to g at x minus f at x. So what we're going to do is we're going to go and we're going to find all these different points. So I go back up to my graph here, and I'm going to say to myself, remember, when we're doing these things, we're finding when we're subtracting, adding, multiplying, dividing, what we're doing is we're finding where the x values are the same, and we're performing the operation on the y values. So first off, I'm going to actually answer what my domain is first. Our domain has to be where the 2 graphs both exist at the same time. So G here has to essentially stop at -4, because when x is -4, that's where f stops. Now, G stops it when x is 0. So f is going to have to stop when x is 0 as well. So our domain, friends, will be from -4 to 0. Now, what's really, really important here is they even leave us a nice blank. I love that they leave us this blank. I wish they did that in 30-2. Okay, I'm going to write the domain. -4 to 0. If I write my domain like that, I will not receive full marks. That is not proper set builder notation. So let's go and put in our proper set builder notation. Okay, you have to write it properly to get full marks. Now, if you want to use integral notation, boom, there it is. Okay, but you have to write it correctly. Got it? Okay, so now all we're going to do is now we're going to go and sketch this new graph. Now, what I'm going to do, just for the sake, so I'm not scrolling back and forth over these 2 pages, is I'm just going to draw it right here on one of these grids. And I'm going to go for hot pink, because we just don't have enough hot pink in our lives. We need it more. So again, what I'm going to do is I'm going to start at -4. I'm going to add the y values together, and I'm going to show this calculation. So I'm going to show somewhere h at -4 is g at -4 minus f at -4. G at -4 is 5. F at -4 is -2. And so you see that subtraction, right? That's where we start getting into trouble, like I was warning you about earlier. And so our new coordinate pair, I'm just going to put it up here, will be right there on that graph. And now that we found one, friends, what we're going to do is we're just going to keep picking our way through the rest of the points and making sure that we've done every single one. So now I see at -3. So I'm going to say h at -3 is g at -3 minus f at -3. G at -3 is 0. F at -3 is 1. So that's -1. That's the point. -3, -1, right there. And all we do is we just keep trucking here. How many more points are we going to have to do? Looks like 3 more. Okay, so I mean, you get the idea. We're just going to keep going and find every single point. H at -2 is G at -2 minus F at -2. That's -3 minus 2, -5. So we got the coordinate pair -2, -5. And continue with my rainbow over here. Let's go. They give us at 1. So H at 1 is equal to G at 1 minus F at 1. G at, -1. My apologies. That's 1 minus, 4. I'm reading this incorrectly here, aren't I? G at that's -4. Now this cold is catching up to me, friends. That's -5. So now we're at the point -1, -5. Right there. And we've got one more to go. And our last point we're going to do is H at 0, which is G at 0 minus F at 0. And G at 0 is -3. F at 0 is -2. And that's -1. So 0, -1 right there. And so now all I'm going to do at this point is I'm just going to draw this thing out. And on the other grid, they definitely had more room for me to draw. Okay, but because I'm squeezing it in there, it's going to look just like that. Okay, and in fact, I shouldn't have that arrow right there. I'm going to stop right at -4. So I'm going to draw that line just one more time. I'm going to stop right there. And I would label that. That's my H at X. Okay, so there's what we're going to do. And then it asked us to find the y-intercept. Well, the coordinates of our y-intercept are at -1. Again, it's coordinates. Write it as coordinates. 0, -1. Okay, there it is. There's your second part of that question. So again, what I want you to think about is just showing as much work as you can, labeling everything that you can, and writing it out on your scrap piece of paper first, and then, friends, transferring it over onto your good paper. I want you to think you've got 6 hours. Take the time and just slowly go through that thing. All right, here we go. Algebraically solve. So algebraically means you can't just stick it in your calculator. You won't get any marks. Solve the equation. Secant squared plus secant is equal to 2. And we've got our domain in radians and state the solution as exact values. So I'm expecting fractions as answers here, no decimals. Okay, so here we go. Let's solve this thing. So first thing I'm going to do is I'm going to subtract over the 2. I'm going to make myself a trinomial. Now, I'm doing something wrong on purpose here. I'm going to factor it. I like factoring. Factoring is good. But I just made an error, or at least something that's going to cost me marks. Friends, we must have equals 0 here. It's an equation. You have to have that. If you don't have that, you will lose marks. If it's equal to 0, you better write equals 0. Okay, now we're going to use the zero product property. So I like to write therefore and give them a little statement as to the fact that I'm using some logical reasoning. And now I'm going to solve each of these for secant. I don't like working with secants. I could if I wanted to, but I'm old and I'm sick, so I prefer to work with cosines like that. Okay. Now, to solve this thing, you're either going to go to your unit circle or your special triangles, and I always solve myself from 0 to 2 pi first. So from 0 to 2 pi, cos is -1/2 at 2 pi over 3, and at 4 pi over 3. And from 0 to 2 pi, cos is 1 at 0 and 2 pi. Rads. And I would prefer myself if we wrote rads behind everything. I think we should, but you don't have to. The only time you're expected to write radians behind a value like this is if it was rounded. So say we had to round something like this. you need to write radians if we're rounding. If we're not rounding, if we're doing an exact value, you don't need to round. But me personally, I think we should just always write our units. I think it keeps things nice and clean. Okay, so I'm sure some students would stop here, but not us, because we know our domain is 2 pi to 3 pi. So all we really got to do is go and find some coterminal angles here. So what we really want is, therefore, our angles that we're looking for is we're just going to add 2 pi to each of these. And so if we add 2 pi, we're going to get 8 pi over 3 like that. And that's going to help us. 4 pi over 3, if we add 2 pi, will be outside of our domain. And it wouldn't hurt, of course, friends, to go and, draw a picture and show what you're thinking as well, right? Like cosine's negative here and here. So when we go to find 2 pi to 3 pi, we're only talking about this region here, right? For that one. So 4 pi over 3, if we add 2 pi, will be outside of our domain. And then likewise for 0 and 2 pi, well, 0 is not in our domain, but 2 pi is in our domain. And 3 pi, we don't want. That would give us a cos of -1. Okay, so the solutions are this, and I'm going to box it. And maybe I say, to keep it nice and clean, on the domain of 2 pi to 3 pi. Okay. So again, I think the reason why students lose marks here is something easy. They forgot to write that equals 0. They do that that's an easy thing to forget. Okay, we really, really need that. Okay, so there's part A for 3 marks, algebraically determine a solution. And at that point, friends, I would go back and graph that and make sure my answers are correct. I'd maybe even do it in degree mode. That's fine. All right, what do we got here? We got points A, B, and C are on the terminal arms of an angle drawn in standard position as shown below. These angles are the solutions for theta to a single trigonometric equation. State the general solution for this equation. Okay. Now, one of the things about general solutions is if I wanted to be lazy, all I'm going to do is just write 3 general solutions, but I need to figure out where these are first. So if this one here is at the reference angle is pi quarter, that means theta for this guy here is 3 pi quarter. This one here is at 7 pi quarter, and B is at pi. Okay, if I wanted to, friends, I could write those as 3 separate statements. So to get back to 3 pi quarter, I'm just writing my general, it's like all my coterminal angles. And don't forget, n's a member of the integers. You could use z, which is the proper notation for integers, but for some reason in Berta, we just don't write that. Don't ask me why, I don't know why. Okay, but you could use capital Z. And so again, what I'm trying to say here is this is a general solution for all 3 of these. I could just do that. That is a perfectly acceptable answer where n is a member of the integers. A slightly better solution that I recognize is that the distance between 3 pi quarter and 7 pi quarter is pi, or 180 degrees. So another way that I could write this is this. Theta is equal to, I'm going to combine those 2 things together. So I'm going to say 3 pi quarter plus n pi, and a member of the integers. And again, I'm just going to leave pi off by itself. It's all sad, but I could leave it just like that. Okay, so there it is. Again, if you'd like to, you could do that question in degrees. Just be really careful that you're answering in the mode that was given to you. And we were given this in radians, so I better write that in radians. Okay, that's kind of just my pointer there. And again, a general solution, we don't really have to create it as 1. It's cleaner if you do write it as 1, but it's acceptable to write it as 3 separate statements instead of 2. Okay, there's our general solution. We got one more question to go. Question 3, what do we got? All right, we've got Given students in a math class are creating and exchanging encoded messages with a partner, right? The old days when you're in elementary class, right? You pass notes. And given that there's 630 different pairs of students are possible, algebraically determined. So again, show me your work is what that's meaning. The number of students in the math class. Okay, first thing we have to determine here is, does order matter? We're making these different pairs, given that there's 630 different pairs of students. Does it matter how the students are paired together? No, it's like the handshake question. How I shake someone's hand doesn't matter. The order doesn't matter, right? So this is the same idea. There's 630 pairs of students. The ordering of those pairs of students doesn't matter. Now, algebraically determined. Well, to determine this, I need to go to my formula sheet and use my formula for combinations. Now from here, what I like about these written questions, friends, is that to me, for the most part, they seem rather straightforward. It's just, here's the question, go and calculate it. Okay, I expanded the numerator because it's got more terms than the denominator, and I stopped at n minus 2 factorial. Well, 2 factorial is just 2, the kids tell me. Now what I want to notice is that n minus 2 factorial and n minus 2 factorial divide out, just like that. Okay, again, I'm really going to take my time on these questions. And I'm just going to rewrite my next line so that the person marking, it's crystal clear to them what's happening. Okay, I'm going to multiply both sides by 2. What's that? 1260. Now I'm going to distribute my n and bring over my 1260. Now I need to factor this thing. Okay, so it takes a second to factor this thing. You know, you're going to have to pick up your calculator and play around with it a bit. So it's n minus 36, n plus 35. So what do we end up with? Well, therefore, n is 36 or n is negative 35. Okay, but wait a minute. I did it on purpose. Even though I'm sick, I swear to you, I did this on purpose. Friends, I talked about it earlier. For full marks, we must have equals 0 there. I get it. It's just easier. Just like drop it. No, you have to show that to me. Now, one more thing, friends, that I want to have here. N is the number of students in this class. I can't have negative 35 students. What I need you to do is cross it off and write extraneous beside it. I need you to do both. Cross it off and write extraneous. Or you could write me a little sentence and say, I can't have negative 35 students. It is extraneous. Okay, but I need you to denote somehow that you can't have it. Can't just ignore it. Boom, n is 36. Again, it never hurts to make a concluding sentence so that the person marking, there are 36 students in the class, in the math class. I guess I should be precise. Okay. Again, make sure you're crossing off and writing extraneous. That is incredibly important. You're communicating why you're not using the negative 35. You have to do that. All right. One more to go, friends. So, and my voice might just hang in there until the end. Let's find out. A student is asked to encode the word factor by replacing each letter of the word with a different math symbol. Interesting. There are 10 different math symbols available. The student creates a list of his letter symbol replacements and gives it to his partner to decode the word. B, explain. Okay, the word explain is a directing word. And what I want you to think about when you're looking at these directing words is they're in the document themselves. If you just pull up this document, and where are the directing words? Right here. Okay, you should have an idea of what these directing words are. So explain, make clear what is not immediately obvious or entirely known. Give the cause of or reason for. Make known in detail. I want to see some words is what I'm getting at here. So let's answer the question, and then we can explain as we go. And again, I would do this on my scrap paper first. So what this student's doing is they're making a key, or they're making a code word for factor. So what we've got is that for the first, they're using 10 different math symbols. So there's 10 different symbols that could go here. And then there's 9 symbols here, 8 symbols, 7 symbols, 6 symbols, 5 symbols. Please, what's really important here is show me your operation. Communicate to me that you're multiplying these together, because it's a symbol and 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 a symbol, and we know means multiply. Okay, so what is that? Well, if we take the other way to think of this, this is a permutation because order matters. There's 10 objects. We're arranging 6 of them. I go and pick up my calculator and I put that in, and I'm going to get 151,200. Okay, but now what I want to do is I probably want to explain a little bit further using some words. So I'm going to write something, and again, I would have perfected this on my scrap piece of paper. I would say something like, since we are arranging the symbols in an order that matters, this is a permutation. I mean, something like that is probably good enough. I could have maybe talked about the fundamental counting principle if I wanted to as well. And then I would maybe say something like, there are 10 objects or 10 symbols. Probably going to say symbols instead of objects because that's what they're talking about. We arranged 6 of them. Okay, that's a pretty good explanation. My work's clear. The person marking on their 4th day up in Edmonton, marking thousands of 30-1 diplomas, has a pretty good understanding of what I was attempting to do. They can see it. I think it makes pretty clear sense. Okay, so again, friends, what I want you to take away from this is you're not getting these questions on your diploma. The written questions are nothing to be afraid of. They're nice and clear. Okay, so again, things that my students are losing marks. I want to see equal signs down the page while I'm doing my work, whatever that happens to be. Okay, so if I'm simplifying an expression, give me some equal signs as you're doing it. Okay, whatever it is you happen to be doing, I need equal signs. Abbreviations are a no-no. No abbreviations. No. So if it was a transformation question, I do not want you to write VS by 3. Okay. First off, VS, I know what you mean, but you have to write vertically stretched by 3. And of course, I need to list what line I'm stretching about the x-axis. Okay. So abbreviations are a no-no. The only place an abbreviation is acceptable is when we do a proof. So if we do a proof and we have our left-hand side and our right-hand side, and we did a proof, again, as I work down the page, I've got equal signs as I go down the page, not in the middle. You don't know these are equal to each other. You're proving they're equal to each other. When you're done here, the only time in 30-1 and you're allowed to write an abbreviation is at the end here. For a proof, for full marks, you have to give me a concluding statement. Left-hand side equals right-hand side. You can use this filled in box, which is known as the tombstone. Name cracks me up, or you could throw down some Latin, QED. Okay, that's the only time you're allowed to use an abbreviation. Don't use abbreviations. Don't say POD. Write out point of discontinuity. A y-intercept and x-intercept is a coordinate pair. Write it as such. Domain and range. This is not acceptable. You must write domain and range properly. Okay? So it's little things like that. In my sketch, labeling everything in a sketch, keeping equal signs down the page, writing the word extraneous if I'm going to take care of, I have to eliminate an option from my solutions, not skipping any steps in algebraically determined. Answering in the correct mode. I'm in radians. I better answer in radians. Okay. I like to write radians behind everything, but for certain, if you have to round to the nearest hundredth or tenth or something, you must write rads behind that. Okay. In my sketch, it's always a good idea to label my function. If, for instance, friends, there was on the grid here, if there was no numbers given to me, I do not assume that each of these tick marks are at 1. So if there was no numbers given here, I expect you to write those numbers in. Do not make me assume when you're marking that the scale is 1. Okay, so you can see how precise we are when we mark these in Edmonton. Okay, now thankfully I'm marking 30-2, so I don't have to feel bad about marking these 30-1 questions. Now, the last thing in this document, which you can download yourself as I'm scrolling back through it, is a sample scoring guide. So here is how the person who runs 30-1, one possible way that you could show your work. Different ways here. But then what I really like, friends, is go through the scoring guide and you can see how we holistically benchmark our scores, and you can see different ways that you can demonstrate to get a proper score of 2. And even better, friends, is you scroll through, there will be sample student responses. Okay, so please go through these responses, see what's acceptable, see what's not acceptable, and judge for yourself how you were doing. Okay, so the solutions are all here for you. Hopefully my solution matches their solutions, right? There it is. And I believe at the bottom here, thought there was sample student solutions, but maybe I'm incorrect. Oh, examples of students' work right here. So you can again see these are photocopies of students' works, and you can see what they did to earn the scores that they did. Okay, friends, I hope that helps. I'm losing my voice. I am out of here. Good luck on your diploma. I wish you well.